Welcome to day 2 of Play NYC 2020. We've got 3.5 hours of gaming goodness lined up for you today. To kick things off, Patrick Alvarez from New York's own Avalanche Studios is here to give us a peek at how he helped build the sweet, sweet destruction that's a trademark of Just Cause 4. Check it out.
Hello, my name is Patrick Alvarez. I'm a game developer from New York. I grew up in Staten Island, or Shaolin to be specific. I went to school for game development in Full Sail University and spent a few years working on my own indie game after that. I also did part time work at a summer tech camp, which helped me learn more about Unreal 3 and technical design after like programming and conventional design classes. Um, Eventually, I got picked up by Avalanche Studios New York, and now I'm one of the three destruction designers that worked on Just Cause 4. This talk will be about our work during the production of the game. Destruction design is a craft that has been with us, with our industry since the pixel era, from Space Invaders, exploding ships, Doom's Gratify, and explosive barrels to our very own medley of explosive chaos. Destruction is an art that we are all acquainted with. So I thought it would be very cool to share a summary of the experience I went through to get the game's destruction up to par and perhaps surpass its predecessors. So these are the talking points. Um, Basics of destruction, visual language, chaos objects, havoc destruction, despawn buffer, and debris fidelity, which we'll go over. So first, basics of destruction. Um, I kind of wanted to give a brief overview on how destruction happens in most video games and like the way to kind of script it. They're more like just technical design rules or just general rules on the approach that you can take to make an object that's destructible or explosive in a video game. Um, this is like it's gonna like make a lot more sense once I get going. So I'll just start. Um, Most game engines support rigid objects, which are objects that have physics movement and engine. For us specifically, we use in the Apex engine we use a Havoc, which kind of handles all our rigid body physics. Um, Objects in a video game can usually be placed as dynamic or static. Static objects are usually not rigid objects, which is a bit of a thing there. But a rigid object, while being able to move with physics, also has the ability to become fixed, which makes it not work with physics temporarily. It kind of turns it off. But if you know an object will always be static, then it's better to have it in a static state completely because it'll just save on memory. I'm kind of getting more into the technical aspect, but I'm just kind of doing an intro so you understand a little more of how this stuff works. Um, so the first thing you want to do is create you could start with a rigid object or a static object, but you want to create a system that makes the object be able to receive damage. You would do this through to conventional scripting like Unreal 4's blueprints, or I guess in Unity you would have to use C# or something. With Apex we use our own system called it was called the signal system, which is a lot of just visual scripting like nodes and spaghetti code, which is a common thing. Um, right, so you want to be able to make sure that your object can take damage. After you do that kind of scripting, once it dies, you want to script a few things. Just to make an object that gets destroyed, you want to make the object hide or delete itself. You want to play the appropriate VFX, and then you want to swap the pieces for debris. So, like when you have like uh, um, a stone wall and you shoot it with an explosive, um, and it takes enough damage that it dies technically. Um, you want to just like disable that and swap in for other parts, play effects, sound effects, visual, screen shake, anything. It depends on what you're destroying, and that's part of the art and the design aspect. Um, and yeah, and like for example, the debris itself will just be a bunch of rigid objects that are dynamic when they appear. Uh, yeah, with our engine, we actually had a system where you didn't have to spawn things; they were just hidden in a state. Like they would already know where they are, and they would be ready to just be turned on, which kind of helped. Which is one of the techniques that we used. Um, right, if the object is explosive, physics engines in video games also support things like forces and pulses. So if you've ever done any kind of game modding, you might have run into it. But like basically, you create a force in a point and give it a radius, which creates a sphere where rigid objects, things that like are dynamic and work with physics, will get moved apart. And you could tune it for force and things like that. It's physics, and this will make objects move. So like let's say you shoot something, something explodes, objects go flying. But that doesn't actually add damage to things, or at least not if it's not tied into the engine. It depends what you're working with. Some systems can have it. If you have a programmer working with you, it might be a lot easier to have custom tech. But if you're working with Unreal or Unity, it's something that you kind of have to just put together in script. But it's doable. Like yet again. If you're making an explosive, you don't just want to play like a smoke debris. Let's say if something's crumbling, you might want an explosive, maybe some fuel, some bloom effects. Screen shake's always good. Things like that. Now, from my end, I didn't make the effects and stuff, but we had a way to just like hook. We had like a library of effects and sounds that we can just use and plug in. And eventually, over time, the actual like sound designers and visual effects artists would come in and update everything for us. But we would kind of lay down the groundwork for them to help them out, and if they needed changes or help with anything, we would be there. Right, and for an explosive object that deals damage, for an explosive object, when it explodes, you also want it to deal damage. Like I said before, it may not be tied to force. Dealing damage is something you might want to also have to script yourself. It depends if your engine supports it or has a damage system. If not, I'm expecting you to be able to kind of create one, especially if you're trying this out. But basically, anything within a sphere of the explosion, radius of the explosion, should be able to take damage. And you can do things like make it be gradual, so the closer you are, the more damage you receive. And that's just scripting. You kind of can figure it out on your own. And Just Cause 4, we had a damage system. We had these nodes called damage controllers, where like objects that receive that have a damage controller would have health, and they can receive different types of damage, like explosive, physical impact, fire damage, and there's a list, and like it's up to you to design and figure out what kind of things you would build there. Right, so yeah, those are the basics on how to do destruction. These lights will also be available, I hope, with the presentation, so you can take more of a look and further approach to it. So next, visual language. Another thing that's big on about destruction design and just game design in general is visual language. Visual language kind of conveys a rule set to the player without being too explicit about it, or what's the word? Like without needing for exposition. So a good example of visual language is like this picture here with the red doors. Imagine if only one of the doors worked in a video game, but they all looked exactly the same. That's an example of bad visual language. If you know that red doors in a game open, then all your red doors should open, for example. Another good example in most video games is like buildings. Buildings are not destructible in most video games, but in real life, you would. If you hit it with a rocket, you could punch a hole into that structure. But as a rule of visual language, almost every building of a specific size in the video game will not be destructible. Maybe small shacks or something like that, which is the next thing, which is more about rule breaks. But before that, pre-production. Most visual design rules are set up in pre-production while you're still kind of designing the game before you actually go into making it. And it's something you kind of want to be strict about and adhere to as much as possible, except when you have rule breaks, overscope or technical constraint. Basically, if the visual design rules lead to a scenario where you're overscoping a specific feature or a set piece, you might have to bend the rules a little bit or figure out a way to kind of approach that scenario. Same with technical constraints. Like if there's like one of our rules in Just Cause 4 was for all wooden objects to be destructible, but we ended up running into some scenarios where if the wooden object was destructible, it would cause a lot of physics issues, it would cause a lot of lag, and things just wouldn't work well. And to get that to work, it would have taken a lot more time than we could have that we had in production. So we had to make our own. We had to make some edits and judgments and rule breaks, I guess. Also, making something that's not specific to the rule, that isn't part of the rule set. For example, one of the rules that we had was concrete. Concrete was not. We didn't want concrete to be destructible in JC4 because we were trying to approach more destructibles in game, more types of destruction. So we were given the rule to just avoid concrete, but things like metal and wood, like everything that we saw in the world that was of a specific size would be destructible. So this is an example of the visual language examples. So this is what I was talking about when wood isn't like we had that rule of wood being destructible. Well, when it's too close to land, there would be a lot of issues where explosions would cause pieces of collision to just fly through the terrain or get stuck into buildings, and it would cause a lot of issues. So eventually we just clipped. If there was any wood like that's part of a ground of terrain, like a deck or a pier that's like that's already on the shore, that wouldn't be destructible. But as it goes out to the water and the collision bodies of these rigid objects have room to move around when they explode, then we were able to that's an example of it. We had to kind of bend the rules. Another example of visual language is with like chaos objects, for example, in the game. So like, for example, that's a chaos object, that tower there that's falling. So all objects that had red would reward chaos points in the video game, which would help you with game progress. So you knew whenever you destroy something that was red, you'll get chaos objects, which is another form of visual language. So that's kind of like 1, 2, and 2 points. So constraints. This is more about like how we set up these big set pieces and chaos objects. I might have. These 2 slides aren't. So let's go to this one first. Sorry. Creating chaos. Every part of a chaos object is comprised of multiple destructibles. So basically, just cause chaos objects are built out of a chain, like any other building, of destructible objects. So we would have to build smaller destructible objects and chain them together and eventually build pieces. And the way we would do this is with constraints. So as I mentioned before, rigid objects can go into a fixed state just like a static object would. Most objects in the game are in a fixed state until Rico or another agent interacts with them in the game, which is a basic rule that we have at Avalanche, which is like if you poke it, it reacts. Well, the object is not poked by something, it's in a fixed static state to save on performance, which just allows us to create these chain, these highly packed objects highly packed physical objects ready to be played with. So one of the tools that we use to create chaos objects are constraints. With constraints, you can bind objects together. So like you can see here, all these examples of the of pieces that this tower here in the game was actually just built out of 3 specific pieces, which led to building this one tower segment. And then we had 3 variations of that tower segment, and then we just connected them all. And that was done using constraints, which they're basically physical points that kind of like they act as as ways to it's like mechanical parts to fix 2 objects together and also give them attributes like being able to rotate or move like a joint in an arm. Constraints are used for ragdolls in video game characters, for example. So if in your shoulder, if you have a constraint like this here, it will limit your range of motion. It will constrain your motion, but I would be attaching my arm to my chest, and it allows them to move together. So wherever we would place points in the game, to attach different constraint points, different objects, and they would have different rules, which would allow us to make things like this tower that can bend when being pulled by the tether and break apart as it comes down. There are different types of constraints, like I said, like the one for ragdolls. That's a cone constraint. I I forget the exact name of it. Sorry. There's also fixed constraints, which are like just two objects that are fixed together. They're almost static. They kind of just move together, like you just bind them together. There's a bunch of different ones, like hinges, like like things that move, like a lot of vehicles in video games use constraints like for that kind of stuff as well, like door hinges, tires, things like that. It depends, yeah, and a good example of how to check out this stuff is in Unreal 4. If you want to try it out in an open source engine, you can go to the content examples, maps, physics, and they have a bunch of constraints and stuff that you can kind of play with and check out. Next, Evolving Chaos. So this is about our upgrades over from the JC3 period to JC4. During JC3, I was in QA, and as we approached JC4, I was part of the programming team as an auto tester. One of my teammates, Karan Sahu, he was the one that was involved in pre-production and kind of laid the groundwork, like the visual language up for the Destructibles in JC4. As I came in like in the middle of as right as production was like ramping up to help out with building more destructible objects, and one of the things that got advanced a lot between the two games was the way that we handled the scripting logic. In JC3, we used an event system that was very it was very static compared to what we have now. That's a little more robust. Like now we're using visual scripting basically. This is an example of like the most updated destruction logic, like just nodes and spaghetti code. Instead of we basically had like these value boxes that you can like send to events that like we had. So we use an event system in JC3 where you can like send out an event and another object would receive an event, and we would just use text boxes to like send and receive them. It's something that we still have, but like now we also have the ability to use spaghetti code to help with the approach. This actually completely changed the game for us. It allowed for more iteration. It was a lot easier to set up crazy events like you've seen in the game if you played it. It would allow us to create these chain reactions with objects that designers might not have had the time in JC3. We actually ended up adding a lot of like for every single piece that I mentioned before that we built, we had a lot of hidden Easter eggs in each chaos object. So depending on what thing you shoot first, different other things would go off and like little things like that. So if someone decided to, instead of just like hit it with a rocket, what I usually do when playing the campaign, if you're just kind of exploring and you want to really mess with the chaos object, there's a lot there to play with, which is a really cool experience. Let me read the top one. Parts can communicate when a specific one is shot and destroyed. Another one may play. Yeah, okay. Cool. Sorry, I'm just making sure that I got everything. Havoc Destruction. So Havoc Destruction is. Let me not be too confusing about this because it's a little bit. So we use Havoc to run the physics in the game, but Havoc Destruction is a specific Havoc tool to make fractured objects. So this is going to be a little hard to explain. So like for the basics of destruction that I've explained here, this is like scripting your own destructibles and inside of game engine, right? The Havoc Destruction, it's more of an algorithm that just kind of generates it for you. Basically, you just give it a mesh, let's say a wall. You give it to the Havoc Destruction system, and it'll like fracture it for you. And we actually had a lot of ways to fracture. We had like all these templates and things that we can use, and most of this was done in Maya. So for example, the wooden bridge or this big satellite destruction, we were given these art pieces, and we would go in and figure out how to fraction them properly, and then bring them into the game. And it was usually just plug and play at that point. These objects did work with constraints and stuff. So once let's say for like the bridge itself, we had like it was built in segments, and then once brought inside the engine, I would add like constraints and like attach it and like get it ready for what you see there. And like just like every object, it's sleeping until it's hit and poke and it reacts. Another example of visual language there with the legs of the bridge. We tried making them destructible, but they would just cause a lot of bugs there, so we just kind of decided not to. Using Havoc Destruction did require a lot of tech support. Some of the systems were outdated by the time we started playing with them, and it was actually causing a lot of lag. The system needed a lot of work. We were very lucky to have a lot of support from the physics team, and they really kind of helped us with our exploration as we built this. One of the cool things that happened was that we in JC3 there was a system called a despawn table for despawning these pieces that get generated. Once you hit something and a bunch of dynamic pieces start flying everywhere, that's gonna really lower the computational bandwidth pretty quickly. So they have to be despawned. They have to be removed from the world. So we can still have space for other moving parts to be on screen without everything without the frame rate just tanking, right? There was a despawn table system where it would just queue all the parts and they would just go in FIFO, first in, first out, and despawn. And we found ways as we worked together, we kind of thought of ways to fix it, and it was a lot of just trial and error as we built things. Scenarios would come up that we would need to create better solutions. I was not a programmer here, so they would just work their wizardry, and I bet there's a lot more to it. And I know Jax Kerner made a presentation on the programming side of destruction, so you can probably check that out as well. And the rules are there on the kind of stuff that we used for how to determine. So next, the breakable system. This system was really cool. This is more of how I actually built this Unreal 4 destructible blocks, which is instead of like I mentioned before, in Just Cause 4 we our debris objects, our dynamic debris, can just be hidden inside the original version of an object that's going to be destroyed, and they could just they're already loaded into memory, and then they just get their physics get turned on, and then they become visual during destruction. But with breakables, to save on memory, we actually don't do that, and we spawn the items real time. And I know they worked some more physics magic to make things so you can drive a car and not have the object spawn inside of it and things like that. This system was really useful. It was used for everything in the game that's not a big explosive object. So railings, poles, tables, what are those called? Baskets, anything, buckets, tires, footballs. It was really useful across the board, and it kind of reminded me of the Fallout 3 days where you can just jump onto a table and kick everyone's dinner all over the place. And this also worked with the despawn table, so things would just automatically despawn. Oh, and that's one thing I didn't mention, which is really cool. We actually managed to get the despawn table to 200 objects on screen by the time we shipped. So there was 200 pieces of debris that could just be flying on screen and stay on screen without despawning until another object loads. And then we, over time we figured out new rules on how to get them to disappear and stuff. It was a pretty cool experience. So the debris fidelity. I remember in JC3 we had object that when objects exploded, they had this really high fidelity explosive, so we kind of try to keep that going. They're actually not as expensive as you might think. They're really easy. For one, they're really easy to make, and they don't take any additional memory bandwidth, because let's say you have an object with this amount of polys, you can just cut it up into pieces, and you have almost the same amount of polys with a few extra, that's so art wise it could be a lot easier to because there's ways in 3D editing software to cut up parts and just warp them. And then one of the things we did to save on memory and computation was just making simplified collision to little boxes and things like that to just we actually had a way to generate simplified collision, which one of the approaches that was used a lot, but we have to make sure that they still look good in the world when on the floor or moving around. Right, so large collision surfaces are expensive, even if basic. So basically, one of the things, like how I mentioned, like we had like low end collision, like you want basic boxes for collision, so you don't take up computation. Well, on the flip side, if you have like a big piece that's very basic that falls on the floor, that's really bad too, because then that big piece is colliding with a lot more triangles than a small piece would, right? And like things could like the physics computations can generate longer instead of just kind of going into a state of rest. Um, it's cheap to make, and yeah, it's like it was just something that we kind of started doing and it worked, so it was nice to have. So just more examples of like the Fidelity, like that piece that Rico's kicking around. It's just like a simple box, but does the job, Post-mortem. So the signal system, or like version of spaghetti code, was pretty buggy. There were like times that like we would get spaghetti code that would show up that like we thought like we deleted, and like there was like some saving issues, but it was a brand new feature to the engine, and it was an amazing first step towards like upgrading everything, and it really like helped update like the destruction system for us. It proved the good old power of spaghetti. I mean, scripting. It's better read than said out loud. Learning to optimize on the fly, getting objects to feel polished first. Yeah, that's just something that we did. Like, especially because I was kind of new to the technical destruction team when we were drafted, so I didn't really have much experience like polishing things, especially because I've never had shipped the game besides Kit before that, and like kind of learning to optimize was I think that kind of just happened on the fly. But one thing that we always try to do is bring objects to a high level of polish, which ended up kind of causing some good and bad things to happen, because people thought that objects were already done when they actually had never received the proper pass before. It was a small mishap, and then we got everything sorted quickly, and it was nice. New tech coming in to help support big set pieces. So yeah, that like for the bridges and like the big radars, like we updated our tech a lot, and it was really helpful to have that. But you might not always have that, so this is not something that it was nice to have. Being agile helped accomplish more than we set out to do. So like we had our goals, and I feel like we shot for the stars and overachieved. It was a cool experience. Concrete visual rule kind of blocked down some things that we wanted. So one of our visual design rules was that we didn't want concrete to be destructible. But of course, like in JC3, concrete was the like one of the main selling points that we had for like being destructible in terms of the destructible bridge we had in that game. I actually had a few bridges in the game that like had concrete, and like, we ended up not making them destructible because of the rule, and we ended up having to backpedal later on, and we updated some of them and things like that. And like one of the I guess like one of the things is like we just kind of missed that there was a contradiction there in the visual design, because like if some of these bridges are destructible but others aren't, it kind of causes a contradiction. It's good to be on the lookout for that, because you might create a rule that you're set to follow, and like later on you're kind of setting yourself up to have a weird effect. But yeah, besides that, I'm still itching to just make more destruction. It was a really fun experience, and yeah, don't save the world, destroy it. I'm not sure if I mean that. It was just I thought it'd be a cool quote to have. I'm sad that there's no questions, but there's no question system. But I hope you guys. It was a good presentation. Yeah, and I hope it like lets you be able to create something destructible. Maybe see if you can build your own chaos object and just check this stuff out. Cool. Hope you enjoy the presentation. Thanks, guys.